In order to find the key characteristics of this function f of x below here, I really want you to have out your 2 post-it notes. And if you don't have 2 post-it notes, 2 pieces of paper will be fine, or you could even take a piece of paper and rip it in half. We just need to use nice clean edges to help us with this task. Okay, so domain and range are the first 2 things that we need to identify. Well, let's recall that the domain is x values, and those go from left to right, and the range are the y values, and those go from down to up. We always go from small to big. Let's use our post-its to help us cover up the graph for the domain. So I'm going to cover up the graph from left to right, and I'm going to cover up what I'm not using. So I'm not using any part of the graph over there. Looks like my function stops right here. Since we're only dealing with the domain, we're actually just looking at the x values, where it begins and where it ends. Okay, now that I have my 2 values circled, let's jump over and write this in both different notations, or both types of notations. So our smallest point here is -8, and as you can see, it's a filled-in point, so it is included. So this ranges from -8 all the way up to 7, but it's not included because it's open. So we're going to show that as an open bracket. Now we could also look at this in inequality notation. Notice how the start and end are the same. So it ranges from -8. I'm going to skip a bunch of spaces, and it ends at 7. We're dealing with our domain, so we're going to sandwich x in the middle. And they're always less than symbols. Now we just need to decide if it's less than or equal to. So that's how we get it from these brackets over here. So this is a closed bracket, which means it can equal -8, which also reflects on the graph over here. And the 7 would just stay a less than symbol because it can't equal. All right, so let's move on to the range. My range, it looks like I need to cover up the low values to the high. All right, so my low values would be, looks like right here. My high value, or my highest value, oh, right there. We're dealing with the range, so we are just dealing with the y value. So I can only look at numbers on my y-axis now, which happens to be there and there. I can move my post-its off if I want. Well, this one's bouncing all around the place. Okay. Let's write this in interval notation first. Since there are points, solid points, at both -8 and +8, we will use closed brackets. Okay, so -8 to +8, or we could also look at this, because this is our interval notation, we could look at this in inequality notation, which looks like that sandwich again, except now we're sandwiching in y values. They're both less than or equal to symbols because they can both be equal to -8 and +8 according to our graph. Now the great part about the range is that it's directly related to the maximum and minimum value. So if the highest point in the range is 8, the maximum is 8. If the lowest point is -8, the minimum is -8. So the range is so closely connected to the max and min. It's like almost like cheating because it's just copying the 2 values down. A lot of people get stuck or have trouble with increasing and decreasing. Remember, increasing means that the graph is going up, where decreasing would mean that the graph is going down somewhere. Well, let's look. All right, I'm going to start right here at the very end. And notice how if I pull my post-it, the graph goes up, 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 ooh, stops, and then it starts to go back down again. So here is an interval where the graph is increasing. And what values are showing? Well, just the x's. And that's what we're going to record. And I never include the start or end points in my interval notation because turning points can't be included. I think that some people would say that you could probably close off this bracket here, but let's just leave them open. You'll talk more about that when you get into higher levels of math. So I could say this is increasing because our graph is going up from -8 all the way to -6. Or I could look at that as the interval notation. I just did the inequality notation first. It looks like a point, but it's not, so be careful. Okay, let's move our post-its. So I'm going to scooch this guy over. Looks like this is where it started to drop, and then it stops right here. Whoa, right here. Let's try that again. So this is now from -6 to -2, but here is my decreasing interval. So from -6 all the way to -2, my graph is going down or decreasing. So this would be -6 to -2 if I wanted to look at that in interval notation. You getting the hang of it? Let's keep going. Looks like our graph starts to go up again. There it is, bouncing up. So looks like we need to go back to our increasing interval. And again, we are only looking at, it might be confusing right now because you can see the y-axis, but we're only looking where our post-it is touching from -2 to +2, which is our other increasing interval, -2 to +2, or you could write it in this notation, the interval notation. Lastly, our graph here looks like it's going down again. And that point here is from, oh, I put that post-it a little too far over, so from 2 all the way to 7, it's decreasing. So from 2 all the way to 7, and I just showed you multiple representations. Typically, you only have to show one or the other. So let's move our post-its off from all of our graphs, if it's going to let me. It's giving me a hard time. Here we go. And there you have it. So you can see all of the different key features of f of x. Let's move on to g of x, which is directly below. As you can see, g of x is really similar. But the problem with g of x, let me just get this situated first, these post-its. They're flying all over the place. Okay, this one is a little bit different because of this guy right here, this arrow, indicating that the graph is continuing. Let's see what this does. All right, so we know our domain is our x values. So we're looking from left to right. So let's cover up our graph from left to right. But wait a minute. If that's an arrow, doesn't that mean that this post-it just goes on and on forever and ever and ever and almost goes all the way over here? I could just keep pushing it off to the right. This is going to help me to write my domain, though, because my domain starts at -8, which is included, but it goes all the way to infinity and beyond, because 10, 11, 12, 13, 14, 15, so on and so forth. And remember, that always gets an open bracket. There's another way that you could look at this in inequality notation, which would just say that x is always bigger than or equal to what number? -8. So that's another way to look at this. Let's do the same thing with the range. Okay, so my range is y values, so from low to high. So here's my top point right there. I'm only looking at these values, my y-axis values. And, oh, I don't know. Let's keep bringing the graph down, 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 down. Oh, arrow means I just keep going and going and going and going. So where does this even begin? How low does this begin? Well, -infinity. Wouldn't these numbers keep going and going and going and going to -infinity? So -infinity all the way up until higher, 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 7 right here. And 7 is included. I don't have any open points. Well, just ignore those straight lines. So that just means that my y values are from 7 and not above anymore, so less than or equal to what value? 7. So y is less than or equal to 7. Well, we can now get our maxes and mins right from the range. So my maximum, my highest number, is 7, where my minimum, well, technically, I don't know if we could really say that this is a value, but we'll say the minimum is negative infinity in this case, because our graph just keeps going lower and lower and lower and lower because of this arrow right here. All right, increasing. Let's just pick, I don't know, let's pick a couple of them on here. So an increasing interval, where is our graph going up? Well, we can see that it's, let's draw some arrows on here. Looks like it's going up here and there. We read a graph like we read a book from left to right, so it's going up from left to right in those two places. And it looks like it's going down in this section and that section. I'm just going to pick one for each of them, because we did a lot of it above. All right, so I'm going to use my Post-its again. Cover up the graph where it's not being used. And if you ever take a test, remember, just use your hands. They work just as well as Post-its, but I think Post-its work, actually, I lied. I think the Post-its work a little bit better. But on a test, you might not have that option. So we'll use our hands. All right, so this looks like it is increasing, going up from -8 all the way to -6. Remember, neither are included. And let's pick a decreasing one. Oh, let's do this one here. Because notice how this just keeps going down, 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 arrow, arrow, arrow. So this Post-it, remember, we could put all the way out here if we wanted to. So we could actually say that this is decreasing from 2 when x is what compared to 2? Well, x is always going to be 2, 3, 4, 5, 6, 7, 8, 9, bigger than 2. You could also write it in interval notation and say this is going from 2 all the way to positive infinity. I could also do the inequality notation up here for my increasing. So -8 to x to -6.